This video was made possible by StruSoft. The plate elements that we just created also need supports. Line supports can be created with these four components. The simplest ones are line support.hinged and line support.rigid. Then we have the line support.simple, and to get the most control, line support.construct can be used. In Rhino, I have created a line and an arc. As usual, I use the query model objects component to get the line supports from the line support layer. Defining supports using the simplest components can look like this. I have simply input the curves and connected the outputs to go on to model elements. In FEM-design, if you have a completely hinged support, we can see that it has no rotation constraints, and if you have some rigidity, we can see these motion constraints in the 3D space. With the line support.simple component, Boolean toggles can be connected to quickly edit the translational and rotational constraints of the support. If I turn all of these to false, except for the TC, I can quickly create a support that will only have constraints in the Z direction. If I want, I can make it a rigid in the Rx rotational direction. The line support.construct allows for a more precise control over the motions and rotations and the plastic limit forces in the support. With the previous component, I didn't talk much about these inputs. You can give custom identifiers to supports, define the local Y direction. Remember that this must be perpendicular to the curve midpoint axis, so you can basically rotate the support direction around the curve. There might be a use case where this will come handy, but for most cases I think that it's simplest to use the predefined local coordinate system. And with that, set the orient LC as to true, because it will try to align the coordinate system of the element with the world coordinate system. When working with straight elements, you can usually ignore the moving local input. But if you have an arc, you might want to set this to true. And remember, there is a limit to the degree of the curve, so if you're getting errors on that, you might need to edit your curve or split it into smaller parts. Now I have set the moving local to true, and my support seems to align with the curve all the way. If I set the false, the support starts to behave in a way where it's not that simple to interpret the results anymore. Thus, I will be setting this to true. I have added text entities to my Rhino model so that I can see in real time what kind of supports am I creating here. The support data contains the coordinates of the support, so I am using a simple Python script like this and only look at the information that interests me.